The first scientists. How early humans observed nature. A windswept plain stretches endlessly toward the horizon. Tall grass bends and sways in the breeze. The sky above is vast and unmarked by any trace of human construction. No power lines, no aircraft trails, no city glow on the distant edge of the world. This could be any time, any place. But travel back 100,000 years, and this scene becomes the entire world as our ancestors knew it. This is where our story begins. Not in a laboratory, not in a university, but in the raw, untamed world where early humans first opened their eyes and truly began to see. The story of how early humans observed nature is one of the most profound chapters in human history. It's a story of curiosity, of pattern recognition, of survival turned into understanding. It's the story of how we went from being merely in nature to being observers of nature. The first tentative steps on a journey that would eventually lead to modern science. What's truly remarkable is this. Our ancestors didn't have textbooks. They didn't have instruments. They didn't even have a written language for most of this journey. All they had was the world around them, their own senses, and something extraordinary, a questioning mind. And it all started with a very simple act: paying attention. The rhythms of the sky. The night sky is a bewildering tapestry of thousands of points of light, stars scattered across the darkness in patterns that can seem impossibly complex to the untrained eye. Even with modern knowledge, it takes time and patience to learn the constellations, to recognize the planets, to understand the movements of celestial bodies across the heavens. But for our early ancestors, understanding the sky wasn't just an intellectual exercise, it was a matter of life and death. Imagine a small group of hunter-gatherers, perhaps 50,000 years ago, huddled around a fire as darkness falls. Their survival depends on knowing when to move, when certain plants will bear fruit, when animals will migrate, when the rains will come. Without clocks, without calendars, without any written records at all, how do you keep track of time? How do you plan for the future? The answer was written across the heavens every single night. Night after night, the same patterns of stars wheeled overhead in the same direction. The moon grew fat and thin in a regular, predictable cycle, full, then waning, disappearing entirely, then returning as a thin crescent that slowly swelled again. Certain bright stars appeared on the eastern horizon just before dawn, heralding the changing seasons. The path of the sun across the sky shifted throughout the year, reaching its highest point in summer and its lowest in winter. Early humans noticed these patterns, but more than that, they remembered them, passed them on, and used them to organize their lives. The evidence for this careful observation has been found in some of the most unlikely places. Deep in caves across Europe, archaeologists have discovered markings on bones and cave walls, some dating back more than 30,000 years. At first glance, these seemed like random scratches, perhaps decorative patterns or meaningless doodles. But when researchers examined them more carefully, they saw something that changed our understanding of early human cognition entirely. The marks weren't random at all. They were counting systems, carefully tracking the phases of the moon. One particular bone, discovered in what is now the Democratic Republic of Congo and dating back roughly 20,000 years, tells an extraordinary story. Known as the Ishango bone, it bears a series of notches carved along its length with meticulous precision. These aren't decorative flourishes or artistic expressions. They're data. Each notch represents an observation, a record of something changing in the natural world. When anthropologists analysed the pattern of marks, they realised they were looking at a lunar calendar, a systematic record of the moon's phases over several months. Consider what this means. Someone, 20,000 years ago, sat beneath the night sky, watched the moon change shape night after night, and thought, "This pattern is important. I need to remember this." They weren't just living in the moment, they were recording moments, connecting them, finding the thread that linked them together. This is science, raw, unadorned, fundamental science, observation, pattern recognition, record keeping, prediction. Without understanding gravity, without knowing that the moon orbits the Earth, without any knowledge of astronomy as we understand it today, these early observers had grasped something profound. The universe operates according to patterns, and those patterns can be tracked, remembered, and used. Reading the weather. The sky offered more than just a calendar. It offered something equally crucial to survival: the ability to predict the weather. Modern weather forecasting is a thoroughly technological enterprise, requiring satellites that orbit the Earth, supercomputers that process vast amounts of data, and complex mathematical models that simulate atmospheric behavior. Even with all this technology, accurately predicting weather more than a few days in advance remains remarkably difficult. But predicting weather hours in advance? That requires something much simpler: careful observation. On the edge of the African savanna, dark clouds build on the horizon. They stack up vertically, rising like towers into the sky. Their bases are dark and heavy, while their tops spread out in a characteristic anvil shape. With our modern understanding of atmospheric physics, we know these are cumulonimbus clouds, formed by columns of warm, moist air rising rapidly through the atmosphere. We know they will likely bring heavy rain, possibly thunder and lightning. But early humans didn't need to understand why these clouds formed. They didn't need to know about convection currents or dew point temperatures. They just needed to recognize the pattern. Clouds like that mean rain is coming soon. Seek shelter, protect the fire, prepare. The same principle applied to countless other natural signs. Birds flying lower than usual before a storm, the wind shifting direction in a particular way, a certain quality of light on the horizon at sunset that meant clear weather would follow, the smell of moisture in the air, carried on a wind from a particular direction, signalling rain within hours. These weren't superstition or lucky guesses. They were patterns, observed and verified over countless repetitions. Indigenous peoples around the world, whose knowledge systems have been passed down through countless generations, still use these observation techniques today. Australian Aboriginal peoples can read the land with an intimacy that seems almost supernatural, knowing when seasonal rains will arrive by observing the flowering of particular plants, or when fish will be running by watching the behaviour of certain birds. Pacific Islander navigators could cross thousands of miles of open ocean by reading the patterns of waves, the flight of birds, the position of stars, and the colour of the water. This isn't magic. It's systematic observation refined over millennia. What's fascinating is that early humans weren't just passive observers of these patterns, they tested them. If you noticed that a certain type of cloud formation was usually followed by rain within a few hours, you'd pay attention the next time you saw those clouds. Did it rain? What about the time after that? And the time after that? Over years, over generations, this knowledge accumulated and was refined. The predictions became more reliable. The patterns became clearer. The exceptions became noted. Yes, those clouds usually mean rain, but not always. Sometimes when the wind comes from this direction instead of that direction, the clouds pass without dropping their water. This is the scientific method in its most basic form. Observe, form a hypothesis, test it against reality. Refine your understanding based on the results. The language of animals. Perhaps nowhere was early humans' observational skill more crucial than in understanding the animals around them. Deep in what is now southern France, in a complex of caves called Lascaux, extraordinary paintings cover the walls. Created roughly 17,000 years ago, these images depict horses, bison, deer, and cattle with stunning accuracy and beauty. The artists who created them worked by firelight, mixing pigments from minerals and applying them with remarkable skill. But these paintings aren't just art. They're detailed studies of animal anatomy and behavior. Look closely at how a horse is depicted, the particular way it holds its head when alert, ears pricked forward, the exact posture of a bison in motion, its body captured mid-movement with an accuracy that suggests the artist had watched these animals intensely, repeatedly, storing every detail in memory. The animals depicted most frequently are the ones that early humans hunted. These paintings were records of observation, possibly teaching tools, ways of sharing knowledge about prey animals with the next generation. Modern studies of hunter-gatherer societies reveal just how deep this knowledge goes. Successful hunting requires an intimate understanding of animal behavior. What do they eat? Where do they drink? What times of day are they most active? What sounds do they make when alarmed versus when calm? How do they react to wind carrying human scent? A remarkable study conducted with Kalahari Bushmen in southern Africa, who still practice traditional hunting methods, revealed the extraordinary depth of observational knowledge these hunters possess. Experienced hunters could examine an animal's tracks in the sand and determine not just what species it was, but whether it was male or female, approximately how old it was, whether it was injured or healthy, how long ago it passed by, whether it was moving quickly or slowly, and what direction it was heading. This level of detail doesn't come from a textbook. It comes from thousands upon thousands of observations accumulated over a lifetime of paying attention. And here's what's truly extraordinary. This knowledge was cumulative. Each generation didn't start from scratch. Children learned from their parents, who had learned from their parents, who had learned from their parents, stretching back through countless generations. A young hunter learning to track didn't just learn from his own observations. He learned from the accumulated wisdom of hundreds of generations before him. The best observations, the most reliable patterns, the most useful knowledge, it all got passed on, refined, improved with each telling. This is how science works. Each generation builds on the discoveries of the last. Knowledge accumulates, error is gradually weeded out, understanding deepens. Plants, the ancient pharmacy. Early humans didn't just need to understand animals, they needed to understand plants too. And here, the stakes were incredibly high, because while some plants could nourish you, heal you, or alter your consciousness in useful ways, Others could kill you in minutes. Monkshood is one of the most poisonous plants in Europe. Every part of it is toxic. Roots, leaves, flowers, seeds. Ingesting even a small amount can cause vomiting, diarrhea, and heart arrhythmias. A larger dose can be fatal. And yet, if you didn't know this, it might look quite appealing. Attractive purple flowers arranged in elegant spikes. Lush, green leaves. How did our ancestors figure out which plants were safe and which were deadly? The answer is slowly, carefully, and at great cost. Archaeological evidence reveals that early humans had an extensive knowledge of plant properties. At Shanidar Cave in Iraq, archaeologists discovered the 60,000-year-old burial of a Neanderthal man. Not a modern human, but our close evolutionary cousin. Surrounding his body were flowers, not just any flowers, but specific species that we still use medicinally today. Yarrow, groundsel, and hollyhock, all known for their healing properties. Analysis of ancient dental calculus, fossilized plaque preserved on teeth, has revealed that early humans were consuming plants with antiseptic and pain-relieving properties. They weren't just eating plants randomly, they were selecting them, presumably because they'd observed their beneficial effects. But how did they figure this out? Imagine suffering from a terrible headache, a pain so severe it makes it difficult to think or work. You chew on the bark of a willow tree, perhaps because you're hungry and trying anything. And within a while, the pain begins to ease. Coincidence? Perhaps. But the next time you have a headache, you remember. You try the willow bark again. It works again. You tell others in your group. They try it. It works for them too. Over time, this knowledge becomes established. Willow bark helps with pain. What these early observers didn't know, what they couldn't know without modern chemistry, is that willow bark contains salicin, a compound that the human body converts to salicylic acid. In the 19th century, chemists would isolate this compound and modify it slightly to create acetyl salicylic acid, aspirin, one of the most widely used medicines in the world. But you didn't need to know why it worked. You just needed to know that it worked. This process of trial, observation, and careful documentation must have played out thousands of times with thousands of different plants. Some trials ended in discovery, a plant that could reduce fever, ease digestion, help wounds heal faster. Some trials, tragically, ended in poisoning and death. But the knowledge accumulated, which plants could be eaten raw, which needed to be cooked to remove toxins, like cassava, which contains cyanide compounds that must be processed out through careful preparation, which could treat wounds, which could reduce fever, which could ease childbirth, which could induce sleep, which could purge the body of parasites. By the time of recorded history, every human culture had developed an extensive pharmacopoeia of plant medicines, all based on careful observation of plants' effects on the human body. Traditional Chinese medicine, Ayurvedic medicine from India, the herbal knowledge of European wise women and healers, all built on this foundation of observation accumulated over countless generations. Modern pharmaceutical research has validated many of these traditional remedies. Digitalis from foxglove for heart conditions, quinine from cinchona bark for malaria, artemisinin from sweet wormwood for malaria, aspirin from willow bark, morphine from poppies. The knowledge was there, preserved in oral traditions, long before we understood the chemistry behind it. Fire and transformation. One of the most significant observations early humans ever made wasn't about something in nature. It was about what they could do to nature. Fire itself was already a profound discovery. The ability to create heat and light, to keep predators at bay, to make darkness less frightening, to cook food and make it more digestible. But at some point, probably by accident, someone noticed that fire didn't just change things, it transformed them into entirely new materials with entirely new properties. Soft, wet clay placed in a fire becomes hard and waterproof when it cools. That transformation is permanent. The clay can't be turned back into mud. Scattered grains of wheat ground into powder, mixed with water and baked become bread, a new substance with different properties than the raw ingredients. Tough, raw meat becomes tender and digestible when cooked, and lasts longer before spoiling. These weren't just changes, they were irreversible transformations. Understanding this required careful observation of cause and effect. Early humans observed these transformations and began to experiment. What else could fire do? What happened if you made the fire hotter? What if you buried things in the coals versus holding them in the flames? What if you heated different materials? Around 7,000 years ago, somewhere, we don't know exactly where, possibly in multiple places independently, someone made a discovery that would change human civilization forever. They noticed that when certain rocks were heated to very high temperatures in a fire, something extraordinary happened. A silvery liquid seeped out. When it cooled, it hardened into a material unlike anything seen before. Strong, but also malleable. It could be shaped, hammered, sharpened, refined. They'd discovered how to smelt metal from ore. This required multiple crucial observations working together. First, recognizing that certain rocks contained something special. They were heavier, had a different color or texture perhaps. Second, noticing that fire at the right temperature could release that special something. Third, observing that the molten metal could be shaped and would retain that shape when cooled. But it also required something else: experimentation. Early metallurgists had to figure out what temperature was needed. Not just any fire would work. You needed a fire hot enough to melt the metal out of the ore. They had to discover how to control the process, how to create the conditions for successful smelting. This was systematic experimentation, trying different approaches, observing the results, refining the technique based on what worked and what didn't. The discovery of metallurgy, first copper, then bronze, then iron, transformed human society. Tools became more effective, weapons became deadlier. Agriculture became more productive with metal ploughs. It all started with observation and experimentation, seeds and seasons. Perhaps the most significant set of observations early humans made concerned the relationship between seeds, seasons, and growth. For millions of years, humans were foragers, gathering wild plants and hunting wild animals, moving across the landscape to find food as seasons changed. Life followed the rhythms of nature. When fruits ripened in one area, you went there to harvest them. When herds migrated, you followed. When winter came and food became scarce, you relied on stored food or suffered through lean times. But around 12,000 years ago, in a region called the Fertile Crescent in the Middle East, something revolutionary happened. People began to notice patterns in how plants grew, and they began to intervene in those patterns deliberately. If you dropped seeds on the ground, plants would grow there the next season. Not always, but often enough to be noticeable. If you planted seeds in soil, you'd cleared and prepared, tilled, to make it soft and receptive. You got better, more reliable growth. If you selected the biggest seeds from the strongest plants and saved them for planting, your next crop was better still. These observations led to agriculture, arguably the most important innovation in human history, the foundation upon which all civilization would be built. But here's what's remarkable. Early farmers didn't understand genetics. They didn't know about selective breeding as a scientific principle. They didn't understand plant biology, photosynthesis, or soil nutrients. They just observed. Plants that produce bigger seeds tend to have offspring that produce bigger seeds. Plants that survive drought better tend to have offspring that survive drought better. Save those seeds. Plant them next year. Repeat. Over generations, over centuries, this simple observation-based process transformed wild plants into domesticated crops. Wild grasses with tiny grains became wheat and barley with fat, nutritious kernels. Bitter wild almonds that contained dangerous levels of cyanide became sweet, cultivated varieties safe to eat. Small, seedy wild tomatoes became the large, juicy fruits we eat today. Teosinte, a grass with hard seeds, became corn with soft, starchy kernels. Every crop we eat today is the product of thousands of years of observation-based selection, guided by early farmers who were practicing science without knowing that's what they were doing. The first medicines. The observation of cause and effect in nature led to something else of profound importance, the beginnings of medicine. In museums around the world, ancient medical texts survive, preserved on papyrus, on clay tablets, on strips of bamboo. Egyptian medical papyri, dated to around 1500 BCE, list hundreds of treatments for various ailments. Mesopotamian medical tablets from even earlier periods prescribe remedies for everything from eye infections to digestive complaints. Many of these ancient treatments seem bizarre to modern eyes. Ground-up lizards, incantations, amulets, magical formulas. The line between medicine and magic was not clearly drawn in the ancient world, but scattered among the mystical remedies are treatments that actually work, based on plant compounds and medical techniques we still use today. How did they figure out what worked? Through observation, through trial and error, through careful attention to cause and effect. Someone with a wound was treated with honey. The wound healed faster than usual, with less infection. Try it again with the next patient. It works again and again. Over time, honey becomes an established treatment for wounds. What ancient physicians didn't know is that honey has antibacterial properties. Its high sugar content creates an environment where bacteria struggle to survive, and it contains small amounts of hydrogen peroxide. But they didn't need to know why. It worked. Just that. It worked. Similarly, mouldy bread was sometimes applied to wounds in ancient Egypt. This seems like an odd practice until you realize that certain molds produce penicillin, a powerful antibiotic. The ancient Egyptians didn't understand microbiology, but they observed that this treatment helped prevent infection. This is what historian James Burke calls the long, slow accumulation of practical knowledge, observation piled upon observation, success built on success, failure warning against future attempts. Not every traditional remedy works, of course. Many are based on faulty observations or wishful thinking. but mixed in with the ineffective treatments are genuine remedies, discovered through careful observation of what helped patients recover and what didn't. Star stories and memory palaces. Early humans faced a unique challenge. How do you preserve and pass on all this crucial observational knowledge without writing? For most of human history, there was no way to write things down. Knowledge existed only in human memory, passed from one generation to the next through teaching and storytelling. But memory is fallible. Details get forgotten. Information gets garbled in transmission. Without some way to organize and structure knowledge, it would be lost. The solution early humans developed was brilliant. They encoded important knowledge in stories, and they tied those stories to the landscape and the sky. When you look up at the night sky and see the constellation Orion, a pattern of bright stars forming a distinctive shape, you're seeing what people in ancient Greece saw and named after a hunter from their mythology. But cultures around the world looked at those same stars and saw different patterns, told different stories. Why stories? Why not just memorize facts directly? Because stories are memorable. They stick in our minds in ways that raw facts don't. A list of stars is hard to remember. A story about a great hunter placed in the sky by the gods is easy to remember. And once you know the story, you remember which stars form the pattern. But these stories did more than just help people remember star patterns. They encoded practical knowledge. Indigenous Australian cultures, some of the oldest continuous cultures on Earth, have oral traditions stretching back tens of thousands of years. Their dreaming stories tell of the creation of the world and the journeys of ancestral beings. To outsiders, these might sound like myths or legends, but anthropologists have discovered that many dreaming stories contain accurate information about the landscape, where water holes can be found during drought, which plants are edible in which seasons, how to navigate vast distances across seemingly featureless desert. Some stories even preserve memories of geological events that happened more than 10,000 years ago. Stories about the sea rising and flooding coastal areas match what we know about sea level rise at the end of the last ice age. Stories about volcanoes correspond to volcanic eruptions that happened thousands of years ago. The stories preserve the observations, encoding them in memorable narratives that could survive being passed down through hundreds of generations. The breakthrough. What made humans different from other animals wasn't just that we could observe nature. Many animals are excellent observers. Birds navigate by the stars. Wolves track prey with extraordinary skill. Elephants remember the locations of water sources across vast territories. What made us different was that we could share observations, accumulate them across generations, and build on them systematically. A chimpanzee might observe that certain stones can crack nuts more effectively than others. That individual might even teach its offspring this technique, but that knowledge remains limited to what each individual can learn and pass on directly. It doesn't accumulate. It doesn't build into a growing body of knowledge that expands with each generation. Humans created culture, a shared repository of observations and knowledge that could grow over time, that could be added to by each generation, that could be refined and corrected and expanded far beyond what any individual could learn in a single lifetime. This is why we went from living in small bands of hunter-gatherers to building civilizations, from making simple stone tools to landing on the moon, from observing the stars to understanding the universe. It all started with observation, with paying attention, with noticing patterns and remembering them and sharing them with others. Every plant in the world represents thousands of years of accumulated observations, which are edible, which are medicinal, which are poisonous, how to prepare them, when to harvest them. Every animal track tells a story written in the accumulated wisdom of countless generations of hunters and trackers. The sky above, with its wheeling stars and changing moon, represents millennia of watching, of pattern recognition, of using celestial rhythms to mark time and navigate space. Early humans weren't scientists in the modern sense. They didn't have laboratories or peer review or the scientific method as formally defined in textbooks. But they had something just as important: curiosity, careful observation, and the ability to learn from the world around them. They had the fundamental spirit of science. All the technology we have today, computers and satellites and medical scanners, all of it is built on the same foundation that our ancestors laid down tens of thousands of years ago. The foundation of paying attention, of noticing patterns, of asking why and what if, of testing ideas against reality, of learning from both success and failure, of being, in the truest sense, curious about the world. We are still those early observers, staring up at the stars and trying to make sense of the patterns we see. We've just gotten better at it. We've developed more sophisticated tools, more rigorous methods, more powerful ways of sharing and testing our observations. But the core remains the same. The great human story of observation and discovery continues, an unbroken thread stretching back through countless generations to those first curious minds who looked at the world around them and thought, "I wonder why that happens. I wonder if it will happen again. I wonder what else I can learn." That curiosity, that drive to observe, to understand, to know, is what makes us human. And it all started long ago, with someone looking up at the night sky and thinking, "I should remember this." That simple act of observation changed everything. The story continues. We are all part of it. Every observation we make, every pattern we notice, every question we ask, adds to the great accumulating body of human knowledge. We stand on the shoulders of those early observers, those first scientists who had nothing but their senses and their minds and the world around them. And we look upward, outward, forward, still watching, still wondering, still learning.